Hello, this is the first of 4 videos where I'm going to talk about the Big O notation. And before going into that, let me do a brief recap of what we have been doing so far. So far, we take an algorithm described using pseudocode, and we realize that we can have one of two types of algorithms. One type is the one where the running time or the memory space only depends on the input data size. But there's another type of algorithms where the running time or the memory space depend on the input data size, but not also on the input data size, but also on the content. In this case, in the first case, basically what we did is counting the number of operations and obtain a function of the running time or the memory space. And after obtaining these functions, we realized that we could drop the coefficients and the lower order terms, and we will get an expression for the growth rate of this function. In the second case, instead, we had to analyze several cases. We said we are not going to focus very much on average case, but we will on worst and best case. So in this type of algorithms, we also count the number of simple operations, but we have to differentiate between worst and best case, and we get these functions again, and again we drop the coefficients and the lower order terms, and we get the growth rates. So this has been our work so far, and this last part has been rather informal. We drop the coefficients, we drop the lower order terms. I show you using an Excel spreadsheet that these do not affect very much the growth rate, because when n is big, these do not contribute significantly to the function. And this has been our technique so far. We are going to concentrate in a second technique that starts from here. So it takes the functions and do an analysis. Before going into that, I'd like to show you the history of this technique. It's a mathematical technique. So you can know that it wasn't born in the computer science area. It was imported from the math area to the computer science. So in 1894, the mathematician Paul Bachmann, a German guy, introduced Big O notation for the first time in a book he wrote at that time. 20 years later, Hardy and Littlewood introduced the symbol omega. And only almost 50 years later, it was Donald Nutt. Donald Nutt is a computer scientist that by that time he introduces Big O and omega into the computer science, and he creates the theta notation. So you can see that during almost 70 years, Big O notation was used in math, and only in the last 50 years it was introduced into the computer science area. So Big O notation is mathematical notation, was created with the aim of being a mathematical notation to describe the behavior of a function when the argument tends to infinity. And that resembles very much what we have been doing with the growth rates. So the people from the computer science area thought this might be really useful for us, and they imported this notation. And so when you use this analysis, the Big O analysis or the Big O notation, what basically you do, you take a function. It can be any function. Remember, this was born in the math. So mathematicians were analyzing functions, any function. It might be the function describing the growth of the population of a country, or the number of people who got a virus. It can be anything. And after you get a function, and in our case the functions can be memory space, for example, you do this asymptotic analysis and you get 3 different notations. You can get 3 different notations for every function. So you can get 3 different notations for the memory space of an algorithm that doesn't have worst best cases. But you can also get the worst case and analyze it and get the three notations for it, or the best case and get the three notations for it. Or seeing from a different point of view, you get any function and you do asymptotic analysis and you get these three different notations. Some notations, depending on the case, are more useful than others, but you still can get the three notations for every function. So in summary, starting from the function that determines the running time or memory space, you can either calculate the growth rate, as we have been doing so far, or do the asymptotic analysis. And in the next videos, I'll show you how to do the asymptotic analysis. That's for now.